Good evening, everyone, and a very warm welcome to the fibUK March lecture. Our webinar this evening is called fibUK What's Happening 2025, and this forms part of our regular programme throughout the year. We aim to provide an update on activities across the various commissions and publications, which are supported by the FIB community across the globe. My name is Corin Walford. I'm the Deputy Chair of fibUK, and I'm a practicing civil engineer working for the contractor Laing O'Rourke. fibUK is the UK national chapter of FIB International, whose aims are advancing the technical, economic, aesthetic, and environmental performance of concrete construction. One of the ways we do this is through webinars such as this one, and it's my pleasure to be chairing this evening's lecture. So before I introduce our speakers for this evening, I would like to briefly go over some of the live broadcast features which you can make use of during the event. First of all, this broadcast is being recorded, so please bear that in mind. Then onto the chat. Please feel free to use the live chat feature to chat to other participants, and you can also respond to specific threads. Then ask a question. So attendees can ask questions via the Q&A feature in the live chat box. This is the purple icon which you can see on the slide. Attendees can send questions at any time, so there's no need to wait to the end. Questions can be upvoted. We may not be able to include every question in the Q&A, so I will try and prioritize interesting questions that have a lot of upvotes. So do please use this feature, and we'll have a dedicated Q&A session after the final presentation of the evening. Technical issues. So if your video stops working or if your audio drops off, you can troubleshoot the connection by trying the following things. You can refresh your browser and press the play button in the center of the screen. You can check your connection using a test your connection link under the video window, and attendees can use the direct message feature to ask for support by selecting the events team. And finally, you can email the events team, events@istruct.org. So speaker profiles can be seen at the bottom of the screen and useful resources on the side of the screen. Now on to the introductions. So first up this evening, we'll be hearing from Dr. Frakoulis Canovaris, and he'll be providing an update on Commission 4, Concrete and Concrete Technology. Frakoulis is Arup's global lead for concrete materials and decarbonisation, based in London. He specialises in concrete materials, sustainability, durability, and condition assessment. He has contributed to over 400 projects worldwide, including buildings, bridges, tunnels, and renewable energy structures, undertaking key roles such as materials and durability design lead for HS2. He chairs multiple technical committees and has published over 50 articles. Frakoulis has received numerous awards, including the 2022 Engineer of the Year Award from the Royal Academy of Engineering and the 2024 Sir Henry Royce Medal. He is a Fellow of the Institute of Materials, Minerals and Mining and a Chartered Engineer, Scientist and Environmentalist. Unfortunately, Frakoulis is unable to join in person this evening, so we will have a pre-recorded piece. Please do feel free to ask questions regardless, and we will pass them along, and Frakoulis will endeavour to answer later. Secondly, we have Robert Wheatley speaking on FIB Commission 6, prefabrication. So Robert is a technical director for Atkins Realis with 35 years experience in the planning, design, assessment and strengthening of bridge and civil engineering structures, including complex arch bridges and steel box girders. He has particular expertise in design and build contracts, working for contractor clients to optimize constructability and design for manufacture and assembly. He has worked on FIB Task Group 6.5 precast bridges since 2014. Finally, this evening, we will hear from Dr. Jose Matos, whose presentation is on FIB Commission 8, Durability of Concrete Structures, Present and Future Perspectives. Jose is an assistant professor with habilitation at the University of Minho. He graduated and obtained his PhD in civil engineering in the field of probabilistic-based assessment of existing structures. His research fields are asset management, life cycle costs, risk evaluation, and sustainability. He is author or co-author of more than 250 publications in international conferences and journals. He is also a regular participant in international committees, as well as in national and international projects. He is currently chairman of FIB Commission 8, vice president of YABSE, and a past president of Eurostruct. So before handing over to the first speaker, it is my duty to read this copyright slide before we start. So to the institution's best knowledge, copyright permission has been provided for all material shown, and this broadcast is therefore presented in all good faith. If the copyright holder believes permission has not been forthcoming, then the relevant item will be removed, or by agreement an appropriate acknowledgement provided to accompany the e-lecture. So with that, I will hand over to Fraukulis to hear about Commission for Concrete and Concrete Technology.
Hello, everybody. I'm Fraukulis Cannavaris. I lead ARUP's Global Concrete Materials and Decarbonization discipline. And in this presentation, I'm going to take you through what's happening within fibUK Commission for Concrete and Concrete Technology. And why is me that is talking about fibUK Commission for? The reason is that I've been a member of the Commission for several years now and have also been leading task groups and working groups within the Commission. So starting with the scope of Commission 4, that is to collect and validate information with regards to the properties and behavior of concrete for structural applications, considering also different types of loading and environmental conditions. So COM4, of course, Commission 4 is a quite technical group, and the particular interests are on durability and deterioration of concrete and concrete which contains other cementitious materials rather than Portland cement. And of course, there is connection with a separate commission, which is looking specifically at durability of concrete, but more from the modeling side. So in this commission, we're looking more at the properties and the different cementitious materials. That includes, of course, supplementary cementitious materials, but also more novel constituents such as alkali activated binders, geopolymer binders, other low carbon concrete materials and structures. The Commission 4 is also looking into constitutive laws and code type models for traditional and new types of concrete. So what goes into the model code for in terms of predicting the behavior of the concrete, and then this could eventually end up in the Eurocode, and that includes time and temperature dependent concrete properties, but also includes different effects in concrete, different types of concrete, such as flowable concrete, aesthetics, concrete with recycled materials, special types of concrete and behavior modeling of UHPC, which are high performance concrete, lightweight aggregated concrete, self-compacting concrete, fiber reinforced concrete, and others. Some aspects of mixing, execution, and curing, comments and recommendations for performance-based specification of concrete, and comments and recommendations on cement-based repair and retrofitting of materials and composites. So a bit of breakdown, how is COM4 structured? First of all, the chairs is Jean-Michel Torrenti from University Gustave Eiffel in France. So the deputy chair is Tornard Martius Hammer from SINTEF. And COM4 currently contains 7 active task groups, each one of them dedicated in different themes. So the first one is code type models, second TG 4.1 fiber reinforced concrete, then 4.3 on structural design with flowable concrete, 4.4 restoration of heritage and exposed concrete, 4.5 time-dependent behavior of concrete, 4.7 structural applications of recycled aggregate concrete, and 4.8 low-carbon concrete structures. So over the next slides, we're going to talk about what each task group is doing, how far within their completion of their objectives is, and what's next for the task groups. Starting with task group 4.0 on code type models, COM4 calls this task group kind of an ad hoc group that is currently preparing a background document for the materials chapter of the Model Code 2020. So within Model Code 2020, there's a materials section that provides information regarding properties of the concrete materials, calculation methods for property development, and so on and so forth. And the aim is, to have a background document to explain what the relationships and models are within the model code, And the sent was that previously engineers and users of the model code did not have information with regards to the origin of the relationships within the model code and constitutive models. So that background document that TG 4.0 is developing targets exactly that, to provide engineers with the opportunity to identify how relationship and constitutive models in Model Code 2020 were developed and selected. The background document is currently under development. I believe it's close to finalization, and anticipated publication date is 2026. After that publication of the background document, which would be as a bulletin, which are kind of the standard way of publishing outputs from task groups from FIB commissions, this task group will be disbanded. Moving on to TG 4.1 on fiber reinforced concrete. So in the initially shared list of TGs, you might have seen that two of them were missing from the sequential numbering. One was TG 4.2 and the other was TG 4.6. Starting with TG 4.2, there was a separate task group just looking at ultra high performance fiber reinforced concrete, in addition to TG 4.1, which was general fiber reinforced concrete. And at some point within the life of the TGs, it was believed that it's better to merge those groups. So TG 4.1 absorbed TG 4.2 on UHP-FRC, and the combined work between both fiber reinforced concrete and ultra high performance fiber reinforced concrete was initiated. So the aim of this TG is to homogenize methods and design rules for fiber reinforced concrete with those of reinforced concrete and precast concrete. And the topics have been ductility, serviceability, multi-axial fatigue, and impact behavior, durability, execution, quality control, repair and strengthening, as well as sustainability. TG 4.1 produced their landmark bulletin in 2022, Bulletin 105, or exactly on fiber reinforced concrete. Is a very comprehensive document that you can see in its cover at the right-hand side of the slides. On that note, there's a previously, what would have happened is, since the TG 4.1 published its main outcome, the bulletin, it would have been disbanded. But currently, there is a new policy in FIB that enables TGs to operate in a continuous process in order to revise parts of the model code. And why is this important and significant? Is because previously, in order to revise and modify parts of the model code, we had to wait several years, and that was somewhat inefficient. But now there is a kind of a rolling and continuous updating process of the model code as necessary. So TG 4.2 will remain active with regards to this process, and will continue to update the parts in the model code relevant to fiber reinforced concrete as appropriate. Next one, TG 4.3 on structural design with flowable concrete. So by flowable concrete, that accounts for concrete which is highly flowable, but also quite predominantly self-compacting concrete, and also self-leveling concrete. The focus in this case is on material properties, production effects, and structural boundary conditions. And particularly considering the mechanical and structural characteristics of flowable concrete or self-compacting concrete, and any local effects of orientation and segregation due to flow and vibration, mixed composition, peculiarities with mixed designs, and production techniques. Again, the outcome of TG 4.3 is the bulletin, which is ready and will be published this year or 2026. For some time now, since the bulletin is under review, or actually probably under production, TG 4.3 is dormant, and Commission 4 is currently assessing whether the group will continue or will be disbanded. Next one, TG 4.4 on the restoration of heritage in exposed concrete. So the primary focus of this TG is on the aesthetics of concrete surfaces, like architecturally significant concretes designed by reputable architects, as the FIB defines it, and also on conservation and restoration of built heritage in exposed concrete. So in the past, and for the past time, TG 4.4 focused on concrete mix design and casting, aiming at obtaining good quality exposed concrete surfaces with homogeneous appearance. And the state-of-the-art report in the form of a bulletin, together with recommendations, is currently being published. So the bulletin covered good practice and recommendations and guidelines with regards to exposed concrete, and included successful examples as case studies that can be assumed as reference cases. So the bulletin is almost there. I think will be published this year, but the group will be continuing with a new convener, Eduardo Julio from Portugal, on historic heritage. Further on, TG 4.5, this is the time dependent behavior of concrete. And it's a relatively newly formed TG. The primary objective is to identify the limiting aspects during the design of new or assessment of existing structures related to predicting the time-dependent, particular mechanical behavior of conventional and non-conventional concrete types. This, of course, includes heavily creep and shrinkage, but also other mechanical properties. So newly formed, we're currently work in progress in this TG. The first deliverable will be an improvement on the model code in terms of the creep and shrinkage constitutive models. So as that will be part of the FIB's continuous updating process, as previously mentioned. And it's also planned to have a bulletin published at some point in the next 4 to 5 years. So early stages for this task group. Next, we skip TG 4.6 for a region we'll go through a little bit later. The next slide. So next one is TG 4.7 on the structural applications of recycled aggregate concrete. TG 4.7 focuses on formulating design recommendations for structural use of recycled aggregate concrete, and it covers physical properties, mechanical and structural behavior, durability properties, and fire resistance. It's a kind of the main fundamental properties that need to be known for the adoption of recycled aggregate concrete. The bulletin is almost ready. I think I reviewed the final draft after comments a couple of weeks ago, and it's currently being reviewed again by FIB experts and Commission for. So by the way, there are internal review processes before publication of a bulletin, and the reviewing process depends on the type of bulletin. For example, if it is a state-of-the-art bulletin, like the one for TG 4.7 on the structural applications of recycled concrete, or the one from TG 4.2 on fiber reinforced concrete, then it's under the responsibility of the particular commission to review and guarantee for the quality of the publication, which is then published in the FIB website. But if it's not a state-of-the-art document and it's kind of a design guideline, then the FIB rules require approval from the General Council. So this escalates higher up, let's say, to a wider pool of experts for review. The work in this task group on recycled aggregate concrete is almost finished, and it's to be decided what will be done after that. Probably from internal conversations we're having, this TG 4.7 will not be continuing. And that brings us to the final task group of the FIB Commission 4. So it's 4.8 on low carbon concrete structures. So we talked about 4.6, TG 4.6 missing from the list. And this is because TG 4.6 was on constitutive models for concrete with supplementary cementitious materials. And I was the convener of that task group for some years. And what we're doing in that task group was taking the constitutive models within the model code that were developed and proposed for Portland cement concrete, and modifying them, understanding what needs to be changed to account for other supplementary cementitious materials beyond GGBS fly ash, but also considering calcine clays and other natural pozzolans. So we thought that if we create a new TG for 4.8 this time on kind of low carbon concrete structures at a more holistic perspective, it could absorb TG 4.6 and be kind of a separate working group within that TG. So TG 4.8 focuses on what can be done to reduce the embodied carbon in materials, but mainly structural level, because on a materials perspective, from a materials perspective, it's quite well documented and frequently discussed on what could be done to reduce the embodied CO2, but not so much in terms of structural level and construction process level. So this is covered as part of the TG, but also novel mixes and the structural and durability properties are covered. As mentioned previously, constitutive modeling of material and durability properties covered as well, and improvements on structural and construction levels. This is quite interesting because, yeah, there are many experts that are coming together within that TG, and particularly offering their insights on what improvements could be done on structural and construction levels, which is not frequently encountered in literature. The main outcomes are recommendations of recommendation paper for structural concrete journal, which is almost finalized, and we believe it's going to be published in 2026. Maintenance and improvement of the future versions of model code and sections, particularly related to mechanical properties of the concrete. Pre-standard development of prediction models for future Eurocode 2 revisions. And ultimately, this would be summarized and consolidated in an FIB bulletin, which is going to be released in the next 4 to 5 years. So this was the last TG, and as a summary, I would say we can say that Commission 4 has been quite active, obviously, in the field of concrete and concrete technology and advancing or projecting the state of the art for different types of concretes and their properties. Currently in Commission 4, there are 7 task groups. 2 past task groups have merged into existing task groups. And there is one normal TG that is going to be probably disbanded after the publication of the bulletin, but another 3 task groups are approaching completion. However, there are 3 that are actively working with much work to be done in the coming years. And with that being said, I would like to mention that one of the major objectives of the future activities in Commission 4 is to attract more members from the industry. And ultimately, the aim is for these members to participate in the work of Commission 4 or one of its task groups, as well as to specifically contribute to the Model Code 2020 and revisions of the Model Code 2020. So this is a great opportunity, I believe, to be influential and really shape the future of the standards and the model code. And yeah, on that note, if you want to get involved, feel free to reach out to myself or to the Commission for Convenience directly. And with that, I'd like to thank you for your attention.
Great to hear from Frakoulis. Clearly lots moving in Commission 4, so watch this space if you're interested in the concrete materials and technology side of things. Right, let's hear from Robert Wheatley now about what's happening in prefabrication. Over to you, Robert.
Right, thank you, Corin. And welcome everybody to the summary of what's happening in FIB UK 2025, and we're looking at Commission 6, prefabrication. So I'm a technical director in Atkins Realis, and we'll run through what we've been up to. Very simple breakdown of how we're going to look at this. Proposing that we look briefly at the Commission 6 overview and all of the different task groups, very similar to the presentation just from Frakoulis. and then a little bit more detail on an example of precast bridge deck superstructures using UHPC concrete. So Commission 6 on prefabrication has 10 different task groups covering quite a range of structures. We'll go into all of these in a little bit more detail as we go through. Some of these you'll see are more active and some are less active than others, and I think that'll come across as part of our review today. So let's start off with 6.1 as precast floors and precast concrete structures. To date, 6.1 has been updating their recommendations based on hollow core slab floors, and the intention now is to expand this into a more holistic perspective on precast floor systems overall. And they've got two time horizons, up to 4 years, where they're looking at precast floor systems as an overview, large openings and how to detail around the large openings, installations in floors, and diaphragm action. And beyond the 4-year horizon, they're looking at reassembly, that's disassembling and reusing precast floors, seismic considerations, further detailing rules, and flexibility in use. The last meeting was in October 2019, so I'm not entirely 100% sure how far they're getting on with their 4-year plan on this, but hopefully we should be seeing some more technical bulletins covering precast flooring. 6.2 covers quality control for precast concrete. It's fairly straightforward. Scope for that is to produce a state-of-the-art report on procedures and rules for quality control for production and in product quality. This is probably going to be in conjunction with PCI, Precast Concrete Institute in the United States, and covers the topics you'd kind of expect under a quality control approach, looking at quality assurance, the materials and accessories being used in the plant, production details, transport, erection, testing equipment, and quality control operations. Again, this was due to be produced in 22, and the team haven't met face-to-face since 2019. So I'm hoping to see some more work on that one. Now, 6.3, sustainability of structures with precast elements, a really interesting topic. And we have a bulletin that was produced in 2018 on sustainability. But this is where it starts to get a little bit more complicated. They're now looking at a document to produce a practical application of the sustainability models that they published in 2018, but also collaborating very carefully with Commission 7, which is towards sustainable structures. Commission 7, as was presented last year, have a special activity group looking into sustainability, and that started off in 2023. So I suspect that a lot of this is now a risk of overlap between the different commissions, and they're probably all working together to produce one document. So hopefully we'll see some more work on the sustainability models, either from commissions, the task group 6.3, or possibly coming out from the special activity group, because the actual report was somewhat overdue in 2022. 6.4 is a really interesting topic, I think, on precast concrete towers for wind power generation. We all know that wind energy production is increasing. There's increasing demand from across UK and Europe for more wind power, and with government freeing up more opportunities to do that. The precast concrete towers can be competitive options compared to steel, and are more durable in a marine environment than those steel structures. So this could be a really interesting document on the state-of-the-art of these tall, slender structures to support wind power generation. And the coverage will cover the typologies and design, so fabrication and transportation, erection and then inspection and maintenance of these wind turbines, and including stuff on the environmental impact and how they interact with the electromechanical devices. Again, this publication is slightly overdue, so I'm hoping that we can see something on this topic very soon, because it looks like a really interesting case. Skipping over 6.5, which we'll come back to, we've got a section 6.6 on seismic assessment and retrofit of precast concrete buildings. So there was Bulletin 78 was produced in 2016, and they're now working on a new technical bulletin, again with PCI, covering lessons learned, identification of critical vulnerabilities on precast elements, simplified assessment methodology for seismic considerations, some retrofit strategies, which are then going to be summarized through some scenario flowcharts and high-level evaluation of the pros and cons of those solutions. Hoping to see something on that one shortly as well. These are all a little overdue. I think we'll see the more active groups coming up shortly. So one of the much more active groups now is precast parking structures. This is headed up by Pieter van der Zee at Ergon, and he's covering the advantages of a precast concrete parking structure. Now, I think we're all probably aware that parking structures can be less attractive and less well maintained and less well detailed. And I think this objective of this task group is to change that round and inspire architects and designers with best practice from around the world. So it's a state-of-the-art report, again with PCI, trying to encourage the use of precast concrete parking, and looking at how to best use that space, how to adapt the designs for electric cars and charging points, speed of erection, long span structures, the low environmental impact, how to make the maintenance better, particularly with underground car park areas, safety and aesthetics. And tantalizingly, Pieter's put in "and more," so we'll wait to see what he's got to come up with in his "and more," but it looks really interesting. The timeline is a bit more firmed up around that for Q4 2026 publication, so really looking forward to that. And I've got an example from Ergon. So this is an example of a precast parking structure that had been built at, so it's an extension of the TNZ car park in Bruges with 635 additional spaces in an underground structure, all landscaped in and covered over with parkland. But you can see pictures there of how the product has developed from the factory through to assembly of different units on site, and the overall site set up in a tight urban environment. Another interesting development, kind of springing on from the precast parking, is to look at the social impact of precast concrete. And this one is taking a slightly different approach. It will be a detailed report, but using social life cycle analysis, so to understand how the whole life of a concrete structure is in its social impact, how it creates better living conditions and economic opportunities. So a very wide-ranging, human-centered approach on this. And they're working through they've completed the literature review, working through some stakeholder interviews and workshops this year, with the objective of drafting the report and publication again at the end of 2026. And they're currently meeting an active group. The precast concrete modular buildings, again, this is a new group, so still forming up a lot of their thoughts and structure around this. But they're trying to particularly look at the advantages of precast concrete modular buildings, such as in a whole range of different challenges there that I've listed out. The bulletin is intended to draw a lot on international expertise and give guidelines for different kinds of buildings, ranging from the very simple one-story residential structures to hospitals and offices with far more complicated structures. And they've got some really interesting potential typologies, type contents. As I said, that contents is yet to be finalized, but they're looking at the different typologies of structures, the latest in thoughts around production technology, how robotics can be helping, enhanced properties of concrete, structural connections, how you incorporate all the fittings and utilities in the design, thermal and acoustic comfort, fire and seismic performance, reuse and recycling, and the whole life cost assessment. So they are planning on the 2026 publication. So that could be quite an interesting report covering an area where precast concrete really can make a big difference. So my own task group, circling back to 6.5, they've got a very simple brief in terms of studying recent work on bridge structures with precast components in them and provide design recommendations. We've had two documents already published. It says precast concrete bridge continuity in 2020 and conceptual design of precast concrete bridges in 2021. Now, we're still working on the lateral stability of precast concrete girders. This was presented last time I went through Commission 6, and it was nearly complete then, and it's still nearly complete now, and I'm not quite sure what the final hold-ups are. I suspect there are some legalities around the use of the spreadsheet that goes along with that documentation and getting that 100% correct. But it has been very close to publication for some time. And the newer document that we're developing, and I'll show you some more on that very shortly, is ultra-high strength fiber reinforced concrete, high performance concrete for precast concrete bridge structures. And that's collecting experience from different people around the world who are working on this topic. So that should be produced in 2027. Now, one of the key suppliers of UHPC concrete is Jura in Malaysia, and they very kindly sent me some slides that they had presented to the FIB symposium in 2024 in Christchurch. It's a recent symposium last year, and presented by Dr. Hu Teng-Ning and Professor Vu, who's been very instrumental on promoting ultra-high performance concrete, along with engineer Jen Shen and Jen Shen's Tan and Professor Foster. So these are two case studies here that were considered of bridges that have been built in Malaysia recently, and these have then produced some comparison of the carbon impact of the two structures to compare it with other solutions. So the first structure that we're going to run through as an example is a 105-meter single-span Langat River Bridge in Malaysia, and then an 80-meter RTS railway bridge also in Malaysia. The Langat River Bridge is a simply supported span as part of a longer viaduct, but put together as a special structure over the river. You can see here how it fits into the finished road layout and being a wide structure across that skew highway cross section over the River Langat in Selangor, Malaysia, fairly close to Kuala Lumpur. And Jura are very keen to publicise how well they've done. They've put their design awards that this structure has won in some recent award submissions. And indeed, it is a very impressive bridge. What you can see here is the 9 4-meter deep precast concrete U-beams that have been assembled into the bridge. Each of these is 105 meters in length. The bridge is 33 meters wide, so whilst it's carrying a dual carriageway, it also has some wider white spaces, which you saw in the previous picture, which will be for utility routes in the future. These slides run through the construction of these UHPC U-girders. So the factory is busy producing these as match cast. These segments are each about 7 meters in length, as I said, 4 meters deep and about 3 meters wide. And so they're not too difficult to transport on a special lorry. They're taken to an assembly area near to the site and assembled together, and then post-tensioned to draw it all into a comprehensive unit. So these have 4 cables running right through the whole length of the structure in the bottom span, and then supplemented with an additional 3 to top up the mid-span post-tensioning. And then there's 2 overall continuity and stability strands, 1 in each of the top flanges. Once the beams are assembled, they were moved onto a barge by SPMT transporter, then lifted into place with the tandem lift on the barge, and then finished off and cast in situ diaphragm and in situ deck to finish off the structure. Part of the presentation covered the calculations to compare this solution with a steel concrete composite bridge. And the slide I've got here, please don't attempt to study that detail right now. I'm not going to go through all of that in this presentation. The important line is to look at line D, where we're looking at the global warming potential, our carbon equivalent value. And the comparison here for the UHPC bridge is 4,480 tons on the right-hand side, compared to the steel bridge of over 10,000 tons. So you can see the proposal here is that this is a lot, making a very big contribution to saving on carbon emissions for the bridge structure. And that's quite a notable saving. Although I must say there's 3,300 tons in the bridge. That's a lot of steelwork in the bridge as well. The second case study is for the railway bridge in Malaysia, 80-meter span. Again, similar to the river bridge, these are 4-meter deep precast UHPC decks. This time 8-meter long segments and post-tension at the bottom. Similar construction sequence, fabrication, transportation, assembly, and post-tensioning into one unit, and then a tandem lift into position on the bridge deck. These girders can be quite heavy. Typically, about 480 tons for the river bridge. This one slightly less. The comparison figures that Dura have provided for us cover the comparison between a single 80-meter spanning UHPC girder with the equivalent length of the box girders in the approach figures coming up. And again, you can see here, this slightly, again, they were looking at line D. So on the right-hand side, you can see then the conventional bridge is coming in at 7,386 tons of carbon, compared to the Dura bridge solution, the 80-meter span ultra-high strength concrete bridge of 6,500. So not an insubstantial difference between the two approaches. So hopefully that gives you a little summary of the differences between those different kind of solutions, and some of the work that the bridges team are looking at on ultra-high strength precast concrete bridge structures. Again, as Frank Cooley said, the commissions are always looking for more supporters and members. So if you'd like to get in touch with myself or Corinne or the commission chair, then we're always very keen to have more people involved in the group. And thank you very much for that. And I'm now going to hand over to Jose.
Thank you, Robert. So Good afternoon to everybody. My name is Jose Matos, and I'm the chair of Commission 8 of FIB, which is dealing with the durability of concrete structures. And I'm coming from University of Minho in Portugal, for those that do not know. So the Commission 8 is sharing by myself, and the deputy chair is Carmen Andrade, and we have as a technical secretary Monica Santamaria. And the main motivation of Commission 8 is to identify concrete related durability aspects, considering and review current information available on the topic of durability, and provide guidance on materials, methods, modeling, approaches, and engineering models that will assist in optimal durability design of new structures and restoration design of existing structures, which is a topic that grew with the last Model Code 2020. So, scope and objectives of this commission, it aims to develop rational procedures to obtain an optimal technical economical performance of the concrete structures in service, and also to ensure that sustainability, whole-life costs, and associated through-life perspectives are considered as part of the process by which experience gained from practice is fed back to the design, execution, maintenance, and rehabilitation stresses. Commission 8 also works with the durability modeling of the structures, with rational strategies, procedures, and criteria for design, assessment, maintenance, and remediation. Right now, the Commission 8 has a new structure. Since last year. We split the Commission in 4 main task groups. One dealing with the design approaches, that is led by Steiner Anand. The other one, which is related with the deterioration mechanism related to corrosion, led by Carmen Andrade. The other one, dealing with testing and monitoring, led by Francisca Smith. And the last one, dealing with the deterioration mechanism related to other phenomena, which is not only corrosion. And this one is led by Leandro Sanchez. However, we still have 2 task groups that are in, let's say, end of their life. One task group is TG 8.1, that you heard about it recently from Professor Eduardo Julio, who is the chair of this task group. And this task group is dealing with the model technical specification for repairs and interventions on concrete structures. So the task group in house, they produced the FIB Bulletin 102, also the FIB Bulletin 103, and right now we are under the review of the technical report on restoring reinforcement passivity through replacement of concrete cover. So we expect this year to release this technical report, and afterwards this task group will be dismantled. For your knowledge, there were also 2 webinars within the FIB developed by this task group, one related with Bulletin 102, which is the guide for protection and repair of concrete structures, and other one related with Bulletin 103, which is the guide for strengthening of concrete structures. Also, out of FIB, there was a dissemination of all these activities in TG 8.1, and one of them was exactly here in fibUK, where Professor Eduardo Julio presented more detail about this TG. The other TG that remained from the last version of the Commission 8 is the TG 8.4 that will be also dismantled this year. We are finalizing the bulletin related with life cycle costing, design life and replacement cycle. This TG is led by myself and has Anders Solgaard as a technical secretary. You can see one of the main topics that are addressed within the bulletin, and this is a very relevant topic, which is the evolution of the performance of the concrete structures over time, and how different intervention strategies could be taken into account so as to reduce from one side reduce costs, but from other side to keep the performance at levels that are desired by society. So as I told, we plan to publish this bulletin from TG 8.4 this year, and also to organize afterwards a webinar among the topic. So regarding the new task groups, and to better explain there were 4 task groups, main task groups. The Commission 8 is divided in these 4 main task groups, and within each task group we decide to split in working parties. So working parties will be active and inactive, so starting and dismantle within the whole life of the commission, and the task group will remain as a way to coordinate and generate new or dismantle old working parties. So the task group 8.8 is more dealing with general aspects and led by Steiner Hanlon, and has as a technical secretary Joanita Daula. And this TG 8.8 has 4 working parties, one dealing with durability planning, another one with service and ultimate limit state verification for chloride and carbonation induced deterioration, another one with eco-efficient concretes and clicker efficient binders, so the durability of this type of concretes, and another one related with exposure zones. So the WP1 is focused on durability planning, which is a topic that raised mostly with the Model Code 2020, and is covering all aspects of the planning of interventions and so within the durability behavior of the structures over time. So the leader of this package is Ronnie Paul, and it's an ongoing party. The working party 2 is related with the ultimate and service limit states verification. So the idea is to check what will be the effects of durability and corrosion and other deterioration mechanisms, what will be their effects on the limit states that we do have in our concrete structures. This working party is led by Beatrice Belletti. Working party 3, related to exposure zones and led by Joanita Dalwula. Idea is to check the current exposure zones and evaluate how the climate change would affect such exposure zones, which is very relevant for the durability aspects of our concrete structures. Finally, working party 4, led by Stephanie Dirfel, is related with the durability aspects of these new eco-efficient concretes and clicker-efficient binders. The TG 8.9 is covering the deterioration mechanisms related to corrosion. The leader is Carmen Andrade, and the technical secretary is Joost Golikers. TG 8.9 is divided also in 4 working parties. Working party 1, dealing with corrosion initiation, which a leader is Amir Hahimi. Working party 2, dealing with corrosion propagation, leader Carmen and Rad, and Working Party 3, chloride threshold values, led by Frank Papor and Federico Lodini, and Working Party 4, durability of steel fiber reinforced concrete, led by Antonio Conforti. As it's written here, the developed models suitable for durability design will follow design lines of Model Code 2020, as well as TG 3.2 and TG 3.3. And also, they will be based on updating of FIB Bulletin 34. This is a short resume of what is being covered in the 4 working parties. So with respect to corrosion initiation, the objective is to develop prediction tools more accurate than the ones that exist now, and how to obtain correct input parameters for the model, either for environment of the material. Corrosion propagation, the objective is to deal with models on corrosion propagation, and this subject was not treated in detail in the Model Code 2010, but was more detailed in the 2020. And the idea is also to shake it more and go deep and deal with also new and existing structures. Chloride thresholds discuss the subject of corrosion onset due to chlorides, and we'll try to update the knowledge. We'll get information on corrosion-resistant bars as a means to avoid corrosion. The durability of steel fiber reinforced concrete, this working party develops guidance on how to deal with the corrosion of the fibers due to carbonation and chlorides. The task group 8.11 is dealing with testing and monitoring. The leader is Francisca Schmidt, and the technical secretary is Nizrin Makul. This task group is divided in 2 main working parties, one dealing with the testing of concrete and another one dealing with monitoring of concrete structures. So we were studying the accuracy and effects of the concrete testing for durability aspects, as well as all kind of monitoring systems for durability. So the testing of new concrete will undertake a review of relevant test methods for assurance of concrete quality, in particular compliance testing, including a review of their applicability, replicability, and feasibility. Here you have the structure of the bulletin that is going to be published soon regarding this working party. So the mechanisms that are considered and the conformity of the tests for pre-testing, also for pre-testing but in a batching plant, and finally the production testing. Regarding the monitoring of concrete, the idea is to provide an updated state-of-art report of in situ testing methods applicable on existing structures. You have here most of the tests that we are addressing in the bulletin, and the bulletin is ongoing. Finally, we have the test TG 8.12, which is related with the deterioration mechanisms for other phenomena rather than corrosion. This TG is led by Leandro Sanchez, and the technical secretary is Renan Mendeiros. As you can see here, it has 4 working parties. Freestyle mechanism, led by Pranay Suraneni. Abrasion, erosion, and cavitation, led by Michael Vogel. Chemical and biogenic attack and leaching, led by Alexander Bertoni. And internal attacks, led by Leonard Sanchez. Again, the idea is to keep the models in line with the ones from Model Code 2020, as well as the previous models raised on TG 3.2 and 3.3, and also to take into account and making the updating of the FIB Bulletin 34. So, regarding the next meetings and workshops or webinars, I would say that right now we are closing the TG 8.1 and TG 8.4. So most probably there will be a webinar related to each of them until the end of the year. About the meetings, we are planning now a meeting in FIB 19 in France this year that will be held on the June 19 in the morning. So for those that are interested in the topic, you are more than invited to attend and to discuss with us all these activities that we are raising within the Commissionate. Also, I want to raise two conference or congress that are connected with our activities. One of them is the 7th fibUK Congress next year that will be held in Lisbon from June 15 to 19, and it will be connected with all aspects that we are raising here, and we are organizing a commissionate meeting over there. The other one is Israel 2026 that will be also held in Portugal, North Portugal, in Braga, and is related with also everything that is with the application of LCCA, life cycle costs, reliability, related with durability aspects. So you are more than welcome also to attend this conference. So from my side, I am finished. I thank you for your attention, and any doubt, you feel free to contact me. Thank you very much.
Okay, well, thank you to all of our speakers, Fraculis pre-recorded, and Jose and Robert this evening. We haven't got a large number of questions in the chat. There's one that is very long-winded, and I've responded to say if you can make it a bit more specific, then maybe we can pick up one of those topics. But I think meanwhile, we've got about 10 to 15 minutes for questions. So I thought I'd ask Robert a little bit more about what you've been presenting on. So you've got the carbon assessments of the precast bridges, the two. I don't know how involved you were with these Malaysian projects, but it was interesting to see that you'd got about half the CO2 in the ultra high performance concrete versus steel, which seems very compelling, and obviously it's a bit more marginal on the long span versus I think let's call it normal strength post tensioned. Well, it'd be, that's caught my attention. I wonder if you wanted to expand any more on that assessment, which is very compelling, and any of the assumptions that are made, particularly end of life things to do with recycling of the materials.
Okay. Yeah, sure. Yeah, thanks, Corin. I wasn't involved with the comparison, and these comparisons can be quite tricky to do. As I said, the number that jumped out to me was that there was an awful lot of steel in the comparison calculations for a bridge of that size. But we've been doing similar exercises ourselves as we develop these bridges, and steel that is just normal pristine steel does struggle to compete well with concrete. Concrete has done a fair bit to decarbonize their processes. Steel will go through a step change eventually when we get green steel produced, but they've got to completely reinvent the construction, the sort of fabrication process. So we're finding that there's a certain amount, certain products that can be produced from recycled steel are very cutting down carbon quite a lot. So reinforcement, which is typically recycled here in the UK, has got a much better carbon performance than flat steel plates, which you put into a steel concrete composite bridge. So yes, the numbers might be debatable a little bit, but the general performance is that precast concrete is doing a lot better than steel at the moment, until steel can start producing major sections in a green way.
Excellent. So it's not simply a case of comparing the Forth Rail Bridge with a much more modern design. Then it's there's a lot in the materials.
Yes.
Okay, good. I have another question, which you were talking about 6.1, which is about floor systems, and I was just curious.
No, you're not going to ask me about rack.
No, I wasn't going to, but now that you mentioned it, it was more that the slide said in one part about pre-stressed or hollow core systems. And I wondered if for that, the scope of that that task group extends to other floor systems like solid, reinforced concrete, pre-stressed, precast solid RC or composite RC forms which use precast and in situ together.
Yeah, that's the intention. So they have focused previously on mainly on hollow core slabs. So yes, the intention now is to expand this into a much more holistic perspective on other systems. And the first thing they're going to look at is the various types of systems, as you mentioned, that can be used, and how that can be how precast concrete solutions can be used for that structure. I think also if you look at the slides that on the precast parking structures as well, they're also producing precast floor units, but a much more sort of a beam composite arrangement.
Okay, good. Sorry, I just got a message that I couldn't be seen, so I'll move on. I still haven't got any questions that I can. Oh, sorry, I've just seen a lot of questions now that I've rejoined. There must have been something wrong with my connection here. So I'll go through some of those as well. I had one more from me, which is a very simple one, which is precast parking structures. And again, I think that's a great application.
Yeah.
What in a nutshell are the implications on car parks then for electric cars?
Well, the electric cars are considerably heavier than your conventional car. So I recently decided it was time to convert, and got my own electric car. But it weighs in at 2.5 tons for a standard saloon, so that's quite a lot heavier. As suppliers want to increase the battery capacity and get longer range, I think that we can see the weights coming up again. Now, that's not going to change bridges. We've had a look on bridge structures whether the increased weight is going to really impact on bridges, but that's generally controlled more by heavy goods vehicles than axle loads. But for parking structures where you've got a lot of new cars in, then yes, I think there could be some implications. And then of course, if you're starting to put the charging infrastructure in as well, then there's all that has to be fitted and accommodated.
Okay, so quite a bit to think about. Presumably that's then in terms of design code loading recommendations, they'll need to consider what a car park can should be able to sustain then going forward.
I think that would be particularly useful to update that.
Good. Okay, I'll come now to the chat, which I hadn't seen any of those, but now they've come up, so I'll go through them in sequence. Arnab Chakraborty, do you have any work stream with UHPC used in folded plate type structures? That would be a question for you then, I think, Robert.
Yep. No, I'm not familiar with folded plate structures, so can't answer that one really.
Okay. I'll move quickly on. Fatoba Olan Rawaju, how soon can all these expand to other countries, and what research links are available to those of us who wish to contribute to the industry? So that's the second point is a general one. I think both of you have said, do get involved, reach out if you want to get involved with any of these FIB commissions, not just the ones you've heard about this evening. And if you make contact with the events team, they'll be able to put you in touch.
Yeah, I can say something about Commission Night. So a part of the meetings, we have the webinars, and also we have also special sessions within the conferences, like in Antibes, and also special issues in the Structural Concrete Journal. So whenever anyone wants to, everything is a website of the FIB and all the details and all the contacts. So anyone willing to integrate the working parts and the task groups, just send an email, and then it's very easy to jump in and start working and cooperating.
Good, thank you. Okay, we've got an interesting long question here from Raziul Ali, which is 2 parts, and I think he's tried to split it. I'll deal with the second one first. I'm not sure who to direct this to, which is he's looking at the use of laser cut reinforcement from sheet metal. The question is, Can the codes take account of innovative uses of reinforcement, such as what he's proposing, or either now or in future codes? So I don't know how that necessarily relates to any of our topics tonight, but what we'll do is see if we can get an answer for you on that. Andy Truby, then, for the high-strength shells, is special curing of the precast elements normally required?
That's a good question. I have limited knowledge on this, but as best as I can answer it, I don't believe there is a special curing required, other than they are very thin structures. So I think they need to be factory cured in controlled conditions. But once that is what is done and they're demolded, then I don't believe there's any particular special requirements. The special requirements generally are related around the mixing of the fiber reinforced concrete, because they're using steel fibers, and that puts a lot of demand on the mixing process. It's quite difficult to get the mix evenly spread, and the fibers also tend to damage the equipment, so it wears out that much quicker. So I think a lot of effort is put onto monitoring and controlling the mixing process. So I'm not quite answering your question, sorry about that. But kind of where the emphasis seems to be in terms of the research is around the mixing.
Right. I've got a second one from Andy Truby. For durability considerations, is there a consensus around the world on the approach to design considerations? So I suspect, Jose, you might want to take that.
There is not too much consensus. That's the reason why we also have these task groups and these working parties, because FIB is an international association, and this is a good thing because we have people from all over the world. And of course, we have different realities. If we are dealing with America, is one thing. If we're dealing with Europe, is another thing. Asia is another thing. But in FIB, everybody could share their thoughts. And I do think that at the end, the phenomena, if it is, they are studied the same way, it's the same phenomena. So sometimes models are different and the approaches are different, even sometimes, or many times, codes are different, but the basics, the phenomena is the same. So I do think that is a very nice platform to get a common agreement in many of these lines. And the Model Code 2020, Model Code 2010 is the most example of that.
Okay. I was going to try and narrow it and say, if not the world, then how about Europe? Is there even a consensus within Europe?
I think so. In Europe, they're mostly with the Euro codes. There's more consensus on it. Not in everything, but because we also have the national nexus. But there is a most common consensus. Yeah, definitely.
And is it true? I mean, just to pick up on Andy's point there, within Europe, then you say they've got the national annexes, but presumably the model is the same model, and it's just tweaking some parameters for most of what the different the different nations or nationalities do.
Totally agree, and also it's more than that. For instance, one of these working parties dealing with exposure zones. Exposure zones has a large influence on the durability mechanism that we are dealing with. And we all know, for instance, that due to climate change and many other effects, there are changing in exposure zones. So the national nexus not only should be different from country to country, because exposure zones are different as well, but also with the time from time, we need to update it because it's changing. So the knowledge is changing, but also some of these parameters are also changing because of many externalities that we cannot control.
Okay, thank you very much. So that is actually all the questions we've got in the chat, and it's 7:15, so we've had a good session. It's slightly longer, slightly shorter, I would say, than normal, but I'm mindful that with one of the speakers not actually present, maybe some of the questions have been a bit lighter on account of that. So I'll move then towards the closing slides for this evening, if that's all right. And I think the first thing to say is that that's been very informative. There's clearly lots going on. I thought both of those, all three of the presentations, very interesting, and thanks to all the speakers for their time for this evening and for the interesting topics they've covered. As I've mentioned already, and the speakers have mentioned, you can get involved. I'm sure the conveners and the people that involved with each of these commissions and the working groups would greatly appreciate any sort of input that they can get. So do try and get involved. A couple of last points then. So I'll just go on to say that this webcast is recorded, so it will be up on the website shortly for on-demand access. I'm not quite sure the time frame, but it'll be up in a few weeks probably. And then moving on to the very last slide, I think I'll just highlight some of the next. There's some announcements here from iStruct events website, so you can look at these. Go to the website and see what sort of events you want. There's four here that I'll cover. So Eurocode 8, an introduction to seismic design. That's on 25th of March. So you've probably got time to register onto that if seismic design is of interest. And then the second one is a lecture, permanent design solutions to reduce temporary works in facade retention schemes. And again, that's later on this month. So you've got time to register for that if that's a topic of interest to you. And then moving into April, webinar, large panel systems, 3rd of April. And finally, a conference, structural safety and risk conference on the 12th of June. So check out the website if you want. There's many more events besides that. Okay, and I will leave it there. Thank you very much for listening, and good night to everyone.